This is AGNR 131, Soil Science, Lab 3, Part 2, Soil Consistency. So what's soil consistency? Well, whenever you add water to the soil, it's just going to change the behavior of that soil. Soil consistency is usually more of a concern to engineers, but they look at it. Sometimes geologists will look at it knowing to see how a soil will behave when you add water to it, or for instance, if rain's falling on an area, how will the soil behave when it gets a lot of water? We can simulate that in the lab by adding water to soils. So we can actually, if we have a known weight of a soil, which we'll do here, you can see I have a balance in front of me. If we have a known weight of a soil and we add a known amount of water, we can kind of sort of predict how that soil is going to behave in the field. So given a volume of water and a volume of soil, we can say X amount of rain or X amount of moisture getting on this soil will cause the soil to behave like that. So there's some predictive factors that are involved in this whole soil consistency exercise that we're going to do today as well. So we've got two different soils here, and I'll probably end up giving you some data for maybe 3 soils, but I'm going to show you the procedure for determining what we call the Atterberg limits. That's an engineering term, but what we're looking at with the Atterberg limits is that we're looking to see when a soil becomes plastic and when a soil starts to behave as a liquid. So when it becomes as a plastic, if you remember the previous lab or an earlier lab where we did the soil texture by feel method, you could see there was 3 different samples, and I was showing you as I added water to them how they began to all stay together, clump together into one coherent mass. I was actually making that soil plastic. That's what I was actually doing with each one of those different samples. So we're going to kind of replicate that texture, or that consistency, sorry, not texture, that consistency with each of our different textured soils. Then we're going to continue and take those soils beyond the plastic limit until they just start to behave like a liquid. So I got 2 soils here that I'm going to show you, though they should both behave very differently, but give you a very good idea of how soils behave in the natural world too when rain falls on them or when you get excess water concentrated on certain soils, how they behave. Sometimes they fail, sometimes they give way, sometimes they soak it all up, but it's important for us to know that because of the risks that could be involved to health and you know, and human life even on that one. So let's go ahead and get started. The first thing we have to do is we have to weigh a known quantity. It's pretty important for us to have a known quantity. So we're going to start with 20 grams of soil. I'm going to put my glasses on so I can see what I can do. And I'm going to choose the soil over here. If you remember, I go ahead and put my little tare dish, and then I tare it out to 0. And I'm going to reach over here, and I've got a beaker here. This is going to be the beaker for one of them. And oops, what am I doing here? I'm going to add it like this. Maybe not the best way. That's 3.9. This could take just a couple minutes to do, or a couple go-arounds to do this. Okay, so I've got my 20 grams of soil in these 2 beakers, and I've got a dropper that's going to dispense an equal amount of water, and I've just got some regular water here, nothing special. I've got a little glass stir rod to stir it, and I don't really need any of this anymore. I'm just going to sit in front of me, almost like props. So now what I'm going to do is I'm going to start with this soil. I'll put this one aside. I'm going to start with this soil. Now, even if we don't really know what this soil's texture is, it doesn't really matter, but we're just going to start and see how it behaves. So I'm going to count the drops. I'm going to count the drops that I put in here, and then until I get to the plastic limit. So this could take a while. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. I'll come back to this. I'm still counting. That's 20. We'll come back to this and I'll show you. I'm going to continue to add drops. I'm going to mix it together with a stir rod. That was 20 drops, but I'm going to keep track of my drops. It's important to keep track of your drops. And I'm going to use my stir rod to mix this thing up like this, as you can see, until it's all together. You see there's still a lot of dry stuff in through there, so I'm not anywhere close to getting it. Well, I shouldn't say I'm not anywhere close, but you can see there's a lot of dry stuff on the side. And I want to make sure I keep as much of my 20 grams all in there together so I don't mix it up. But you can see that. There we go. If you're a baker, you're mixing flour and water together, you know, you're for like a crumble. If you like crumbles or crisps, you know that this is kind of you want to go past that consistency for sure. All right, so it's taken me about between 60 and 65 drops so far to get it to this point. I've got a little spoon here, and you can see I'm kind of taking it all out. Now I've got a little bit of error right here, but I can fix that pretty quick. But you can see that this is all pretty much a coherent ball. I mean, the whole thing is saturated, has got moisture throughout. So that's pretty much plastic for this soil. It's wet. I can actually change its shape a little bit. Can squish it around, but it's pretty much staying in the ball. So the more I work it out, the more my hands are gonna steal moisture from it. But that's about that. So I've kept track of my drops, and that's 65 drops to get to that spot there. I mean, I'm accounting for a couple extra drops there that I'm gonna probably have to add, or I would probably have to add to get it back to its state. All right, so now I've got this soil to what I consider to be its liquid limit. It's taken me about 90 total drops, maybe a little bit more, counting for a little bit of error, but because I kind of did lose count. I know it's between 90 and 95. So let's just say 90 drops to get it to this point. Now I think it's pretty important for me to focus. If you focus in on that, you can kind of see what that looks like. You can kind of see there's a little bit of water on top of it. Now if I settle that back in there, here I want you to look at it there. Now I'm going to shake it just a little bit, and you're going to see it all goes back into solution. So how is this soil behaving like a liquid? So if you can actually see this, watch what happens when I turn this soil upside down. You see it doesn't really want to flow yet. See, I'm pretty much got it upside down, but right? Can you see that? It's upside down, but watch what happens when I tap it. You see what it wants to do? It wants to start flowing. That's how it's acting like a liquid. So imagine in California, which is where we are, if you actually have a soil that's saturated like that and you have a little bit of an earthquake, what would happen to that soil? So saturated with water that it begins to act like a liquid. That's one of the reasons why it's important to know the Atterberg limits. So this is what we call the liquid limit of the soil. And what you saw before for this soil was the plastic limit. Now, we're going to try it again. So remember, we had about 60 drops to get to the plastic limit, and we had about 90 drops, maybe a few more, to get to the liquid limit of this soil. So you can see now that we can do a calculation quite easily. The only piece of the puzzle that you're missing is how many drops equal some sort of volume other than drops. Well, the common standard for this particular dropper is 20 of these drops. If you've counted properly, 1, 2, 3, 4, 5, 20 of those drops equals 1 milliliter. 1 milliliter of water. 20 grams of soil, 20 drops equals 1 milliliter. So the calculation's quite easy, right? It's in your handout that I've given you, but I'm just telling you verbally as well. Okay. So we're approaching the plastic state on this particular soil. It's a little bit different. I've already added 105 drops, and I'm going to see if it doesn't more or less stay together on that. I think I've got some dry pieces in here, but it looks to me like if I've mixed it well enough, and I have done a pretty good job of mixing it through with a glass rod, I'm going to say that I'm pretty much there. This is about 105 drops is about the best you can get. And you can see it's all staying in one mass. I got a little bit more in here, but I could scoop that out, because again, remember, I mixed it all up, so I know it's mixed properly. So plastic limit, 105 drops for this soil. So we'll take a pause. I'll add a whole bunch more, and we'll see what our liquid limit is on this. Okay, this one behaved a lot differently than the last one. So I've added 225 drops here to get this particular soil to get to the plastic limit. So again, kind of dramatic. If you can focus in on that, you might be able to see it hopefully pretty well. And I'm going to tip it. I'm not sure if I got it quite right, but I'm going to tip it. You can see as tipping it, gravity hasn't quite taken effect yet, but watch what happens if I tap it. It's beginning to move. I'm hoping it's beginning to move. I can't see it, but it should be. Not beginning to move yet? How about now? Just a little bit of movement. You can see it's kind of sliding down there like thick chocolate milk. So really what that's telling me is that 225 is probably exactly on the liquid limit. If it was a little bit more moisture in there, I would probably just be able to give it hardly any movement at all, would start to get that whole soil mass flowing. So still, 225 versus the last one, quite a bit difference. This particular soil can actually hold a lot more moisture before you have any failure issues than the previous one.